The figure shows a bigger disk which is fixed. Bigger disk is not moving, it is not rotating, it is not rolling. On the surface of the bigger disk, there are two smaller disks which are identical, each having a radius of r. There is no gravity. The whole arrangement is placed in a space where there is no gravity. That means these two disks are weightless. So gravity is not acting, mg is not acting on the disk A and on the disk B. At an instant, these two disks are set rolling. Initially, as the diagram shows, that the disks are touching one another, then they are set rolling. One means this one, the disk B is made to rotate about its center of mass with a velocity 2 omega, and the disk A is made to rotate about its center of mass with an angular velocity omega, and they are set rotating in opposite direction. One is, you can see, B is rotating clockwise, A is rotating anti-clockwise. Question is, in what time after the motion starts, the two disks will again touch one another? To solve this problem, we'll have to know a little bit concept of pure rolling and also some concept of relative velocity. In pure rolling, consider a body. This body is undergoing pure rolling. Its center of mass is translating with a velocity v, and the body is rotating about its center of mass with angular speed omega. If the rolling is pure, that means if the surfaces that are in contact are sufficiently rough, then v is equal to omega into r. This is the condition for pure rolling. In impure rolling, if the rolling is impure, v will not be equal to omega into r. So the center of mass of the disk B is moving with a velocity 2 omega into r because its angular speed is 2 omega, and center of mass of disk A is moving with a velocity omega into r because its angular speed is omega. Now we will discuss how we solve relative velocity problems. Let us consider two bodies. One is A and the other one is B. A is moving with a velocity u and B is moving with a velocity v. To solve relative velocity problem, we prefer to make one of the two bodies stationary. How is that done? We apply opposite vector. We apply opposite vector that has same magnitude as u in opposite direction. And to keep the system unchanged, because the system comprises of two bodies A and B, you just cannot apply a velocity on one member without making any change to the other member. That cannot be done. That will change the system, and to solve your problem you cannot change the system. So we have applied u velocity in opposite direction on A to make A stationary, and we are required to apply the same velocity in same direction on the other member B as well. And we will now study the result. The result is A has come to rest, its velocity is 0, u minus u 0, and B is moving with a velocity of v minus u. So this is A this is B, and this velocity of B, V minus U, this is called velocity of B with respect to A. We'll apply the same technique here to make A stationary. We'll apply opposite vector. I will apply omega into R on A, and I will apply the same on B. So this is omega into R. This is also omega into R, and the result, we'll now study the result. Disk A has come to rest, and disk B is now moving with a velocity of omega R plus 2 omega R, that is 3 omega R. Okay. Now I will show the final position of B. Initially B was here. And their centers of mass were at a separation of 2r. Now B will travel along the circumference of a circle. Center of mass of B, this is B, center of mass of B will move along the circumference of a circle of radius r plus r, and finally B will come to this place. B will be here. So final separation between the centers of A and B will be 2r, and their initial separation, that was also 2r. So center of mass of B will be required to travel a distance of circumference of radius r plus r minus 4r. This is 4r. So distance to be traveled, this is linear distance to be traveled by the center of mass of B is equal to 2 pi into r plus r minus 4r. Okay, and the velocity of B with respect to A, VBA, is equal to 3 omega r. Hence time taken by B to reach position B dash, position B dash is equal to 2 pi into r plus r minus 4r divided by 3 omega r. It is given in the problem that r equal to 50 into r. So we'll put, in place of r, we'll put 50r, and we'll get 2 pi into 15(1r) minus 4r divided by 3 omega r. R will cancel. This is equal to 51. To match one of the option, I have taken 51 outside. 2 pi minus 4 by 51 divided by 3 omega.